In an industry where safety and environmental responsibility are so important, making sure you're compliant with regulations is a must. It's not just a checkbox. You need a clear and efficient way to figure out if your pipeline is in good shape.
That's exactly what we're digging into today. We got a bunch of information that goes deep into pipeline engineering assessments. Specifically, we're focusing on what happens when pipelines need to be brought back into service. We've got some real-world examples, a couple of engineering assessments or EA reports, and some pretty interesting details about a service called the TPA EA Reporting Hub.
Two distinct cases here. One is looking at a pipeline that's been out of commission for a good while, and they're thinking about bringing it back online, but they're going to change what it carries. The other case is about a pipeline that was actually built but never used, but now they're finally getting ready to put it to work. These two cases highlight the different factors that come into play when you're doing an engineering assessment. We also have some material outlining the capabilities of the TPA EA Reporting Hub, which aims to streamline this whole process.
It doesn't matter if it's a straightforward process or something more, well, complicated. We want to understand how services like the TPA EA Reporting Hub are tackling these challenges, especially how they help ensure compliance with standards like CSA Z662, that's the big one in Canada, for pipeline safety. And of course, how it all leads to making better decisions.
Let's look at that first scenario, the pipeline that's been out of service for a while. First thing that jumps out is that this isn't just a simple flip of a switch, right? This pipeline's been sitting idle since 2008. It used to carry sour natural gas, but now they want to use it for sweet natural gas.
Okay.
And there's a change of ownership too. Definitely not your run-of-the-mill reactivation.
Right.
The integrity assessment digs into the condition of the pipeline after all that downtime. It points to a moderate risk for both internal and external corrosion. The takeaway is that even though it's been sitting there for a while, and even with some protective measures in place, there's still a real risk that needs to be addressed proactively. For the internal corrosion, they've estimated a potential rate of corrosion, and they're expecting to find some internal damage that was already there before it was shut down. On the outside, though, no signs of corrosion, and the coating is in decent shape. They kept up the cathodic protection while it was offline, so that helped. If you were in a similar situation, changing the product or the owner, you'd probably have to go through this more rigorous non-routine process to meet standards like CSA Z662.
What kind of extra steps are we talking about for a non-routine reactivation?
The big one is a hydrostatic pressure test before they turn it back on. And not just any test. It has to be done at 1.25 times the planned MAOP for that sweet natural gas service. They also need a solid plan to prevent corrosion from happening in the future. Interestingly enough, at this point, they're saying an internal inspection isn't really needed because they think there's a low chance of finding any serious pre-existing corrosion. They want to make sure this pipeline can operate reliably for a long time, and they're doing that through this thorough assessment and the mitigation plans they've put in place. Based on their analysis, they think the pipeline can last for more than 40 years if they stick to those corrosion prevention recommendations.
Okay, let's move on to that second case. This one's labeled as routine reactivation. What makes this one so different from the first? What makes it routine?
It all comes down to the pipeline's history. It was licensed back in 2019, but they never actually used it after they built and tested it. They took it offline right away in May 2020 and did it properly. Because it was only offline for a very short time, and because what they want to use it for, dehydrated, produced gas, matches its original design, they consider this reactivation routine, according to the guidelines. Another thing that makes it routine is that they're not planning to do another hydrostatic leak test before they start using it. The initial test they did during construction is good enough because it's practically brand new.
Right, so much less time offline, and it's never seen any product flowing through it. That definitely changes how you think about potential internal corrosion.
Because the pipeline's never operated and was properly discontinued, they believe there's no pre-existing corrosion damage. They don't think there are any issues with active external corrosion, given how new and unused it is.
The corrosion concerns are lower because it'll be carrying dehydrated gas. What if they change their mind down the line? What if the operating conditions change?
That's a great question. It's all about being prepared. The report does outline a backup plan specifically for controlling corrosion if they ever need to transport wet gas. It involves pigging and meg slugs, just like the other pipeline, although they point out that this isn't necessary for the dehydrated gas transport.
What about the history of pipelines in this area? Is it similar to the other region we talked about?
Interesting thing here is that looking at the historical data, this pipeline segment and even the surrounding area has no record of any internal or external corrosion failures. There were some incidents further out, but the report says those external failures were caused by installation methods that are different from what they used on this newer pipeline. So the regional context here is a bit more reassuring compared to the first case.
That's definitely good news. Okay, so we've looked at two examples of engineering assessment reports. One for a more complex reactivation with changes, and the other for a more straightforward reactivation of a pipeline that's never been used. It's obvious that a lot goes into these evaluations. Now let's talk about the TPA EA Reporting Hub. What is it exactly, and how does it make things easier for pipeline operators?
The TPA EA Reporting Hub is an online service, and its whole point is to simplify the process of creating engineering assessment reports. It's all about making those often complex engineering reviews easier, ensuring compliance with regulations like CSA Z662, and ultimately helping pipeline operators make better decisions faster. They emphasize providing fast, regulator-ready EA reports for a variety of situations.
Right.
This includes routine and non-routine reactivations, changes in ownership, and acquisitions of pipeline assets. So they're trying to move away from those one-off time-consuming assessments and create a more standardized, data-driven system that not only speeds things up, but also incorporates regulatory best practices from the get-go.
That's music to the ears of anyone in this industry. What are the biggest advantages they highlight?
They talk about making the whole assessment process more efficient, which obviously leads to faster compliance, and that in turn helps operators make more informed decisions about their pipelines.
What's the technology behind it?
The platform is powered by TRIAGE by AbaData, a leading hazard classification service in Western Canada. The EA reports generated through the hub are based on reliable data related to pipeline integrity risks, specifically validated for this region. The system connects directly to relevant pipeline data, streamlines the logical steps involved in doing an assessment, and automatically incorporates the requirements and guidance from CSA Z662, the cornerstone of pipeline safety in Canada.
It's built on an established system for understanding risk and directly links it to key regulatory standards. Now, I understand they're taking this even further with an OpenAI large language model. How does that play into improving these engineering assessments?
What they've done is they've taken the TPA EA Reporting Hub and trained a custom OpenAI large language model on it. They use data from over 250 historical engineering assessment reports that TPA has completed. By analyzing all this historical data, the LLM can learn patterns, identify key risk factors, and understand how different pipeline characteristics and operating conditions affect the overall integrity assessment.
So it's like having an AI assistant that has gone through hundreds of these reports and can now help with the process. How does this actually improve the engineering assessment and reporting?
Exactly. This AI model can help in several ways. It can automate parts of the data analysis, pinpoint potential issues or areas of concern based on the historical patterns it's learned, and even help write the EA reports themselves. This can lead to greater efficiency, consistency, and potentially even more insightful assessments because it's leveraging all the knowledge from those past reports. It helps make sure the assessments are aligned with the CSA Z662 best practices that were consistently applied in those historical reports. It's all about making the process faster, smarter, and contributing to safer and more reliable pipeline operations.
What are the key takeaways from our deep dive into these EA reports and the TPA EA Reporting Hub, especially with this new AI development?
Well, the biggest takeaways are that thorough engineering assessments are essential for making sure pipelines are in good condition and can operate safely, especially when you're thinking about reactivating them. The pipeline's history, what it carries, and the overall operational context play a huge role in figuring out how to approach these assessments and what mitigation strategies are needed to meet standards like CSA Z662.
And it seems like the TPA EA Reporting Hub is offering a significant step forward in streamlining and improving this critical process by connecting its workflow to triage and leveraging an AI model trained on a wealth of historical data.
Grounding assessments in regionally validated risk data from triage and incorporating what they've learned from hundreds of past EA reports.
It helps keep our pipelines safe and helps us navigate all the complexities of regulatory compliance.
And the way AI-powered tools are developing in this area is really promising. It has the potential to further improve accuracy, efficiency, and overall effectiveness of pipeline integrity management.
Given all the data we have and the rapid advancements in artificial intelligence, how might the use of AI-driven tools, built on platforms like the EA Reporting Hub, leveraging vast data sets of historical pipeline assessments and regulatory knowledge, further transform how we manage pipeline integrity and ensure compliance with safety standards like CSA Z662 in the future? What innovative new approaches might we see as AI continues to learn and evolve in this critical industry? It's definitely something worth thinking about.